Alrighty then, inductive and deductive reasoning. This is 2.2. Inductive and deductive reasoning. So, you note you're going to copy on page 76. Okay. A conjecture is an unproven statement that is based on observations. So the conjecture would be is, hey, when someone comes in late, Mr. Hop marks them tardy. When someone else comes in late, Mr. Hop marks them tardy. When someone else comes in late, the teacher marks that person tardy. Someone else comes in late, they're marked tardy. Someone else comes in late, they're marked tardy. Hey, based upon that pattern, my guess is that the next person that comes in late, they're going to be marked tardy. Okay. Okay. It's unproven, but it's based on your observations. It's based on patterns. Okay. This would be inductive reasoning. When you find a pattern in specific cases and then write a conjecture for the general case. So it's an unproven statement. Now, it's unproven because sometimes maybe the teacher's writing on the board and someone sneaks in late and they're not marked tardy. Okay. So if they come in late and they're not marked tardy, then, well, that takes care of that. It doesn't work. Okay. So that's inductive reasoning, is when you find a pattern. These pattern occurs over and over. You can't prove that it will always work, but usually it does. Okay. Where in a different case, a different scenario would be deductive reasoning. Deductive reasoning uses facts, definitions, and accepted properties and the laws of logic to form a logical argument. Okay. Deductive reasoning is when you can prove something will occur or you can prove something will not occur. Okay. And this is different from inductive reasoning, which uses specific examples and patterns to form a conjecture. Deductive reasoning, you can prove something does occur or doesn't occur. In inductive reasoning, you cannot prove something will occur or will not occur. Okay, that's the main reason. Okay, so there's things called counterexamples. A counterexample is a specific case for which the conjecture is false. A counterexample is a specific case where the statement is false. Okay, so let's do some examples. An example, question number 9 is on page 80. Make and test a conjecture about the given quantity. Number 9, the product of any two even integers. What do you mean? Make and test a conjecture. So here, the product of any two even integers. Product means multiply. Even integers has to be an integer. It has to be even. And we have to have two of them. So I'm going to multiply even integers. 2 times 2, 2 times 4, 2 times 6, 2 times 8, 4 times 5. There's a whole bunch of cases. I'm multiplying some even integers. Okay? And when I do that, I'm going to look at my answers. Hey, here's my answers. What do you notice about the answers? There's a pattern there. What do you notice about that pattern? Okay, this is just a conjecture, but I'm going to say if you take the product of any two even integers is an even integer, if I can say that properly. So my answer would be the product of any two even integers is another even integer. Okay, and here's a whole bunch of examples. I just wrote down, you don't need to write down all these examples, but it certainly helps to make that pattern visible. Okay. Question 13. Question 13. Here's question 13. Right there is question 13. Question 13, let's scooch that down a bit. It's question 13, find a counterexample to show that the conjecture is false. So counterexample, we just need to find one case where this thing is going to be false. And the trouble is, where is that one case? You have to find that one case. So the product of two positive numbers is always greater than either number. Products, that means multiply. Positive numbers, it could be a decimal, it could be an integer, it could be a fraction, but it has to be positive. So multiplying two positive numbers. So here we go. Here's positive numbers right there. 4 times 5 is 20. Is this bigger than both of those? Yes. Okay. 2 times 30. Is this bigger than both of those? Each one of those? Yes. What about this one? 40 times 2. Is that answer greater than both of those? Yes. How about this one? 8 times 1 equals 8. Is this bigger than both of those? No. Is 8 bigger than 1? Yes. Is 8 bigger than 8? No. 8's equal to 8, but 8 is not bigger. Okay? This says the product of any two positive numbers is always greater than either number. This is not greater than 8. So there's one case. That's a counterexample. Here's another one. Okay? It doesn't say integers. It just says two positive numbers. So there's a positive number. There's a positive number. Okay? 10 times 1/2 equals 5. Is this greater than 1/2? Yeah. Is this greater than 10? No. So there's another counterexample. So don't use those. Make up your own, but it's going to be really similar to that stuff. Okay? So you're going to have to find a counterexample for each of these. Okay? Next, the law of detachment. So law of detachment. So law of detachment's on page 78. So on page 78, when you copy this stuff in your notes, page 78 in your notebooks right there. Okay, here's deductive reasoning. Law of detachment states, if the hypothesis of a true conditional statement is true, then the conclusion is also true. So here is law of detachment. So law of detachment. So if P then Q, that's in symbolic form, and if P then Q, that's exactly how it's written. If P then Q. So if you're given that if P happens, then Q happens, and then you're told, hey, P occurs. Can you make a conclusion? Yes. If P occurs, then you know that has to occur. So if P occurs, the conclusion is Q must occur. Okay, that's using the law of detachment. Here's another example. Okay, so right here. Here's R, here's T. If R, then T. Okay, if R happens, then T happens. And if that's a true statement, the next part would be, hey, T does occur. You're given that. You're given this, and you're given this information. T occurs. Well, if T occurs, can we make a conclusion from that? No, we can't. This is the second part of the conclusion of the if-then statement. So because this part occurs doesn't mean that one has to occur. Remember, that arrow is going this way. So if this one occurs, then that has to occur. The arrow's going that way. But if T occurs, it does not necessarily mean that has to occur. So in this case, no conclusion possible. In this case, there's no conclusion possible. Okay? So, let me give you another example. Okay? If C, then W. And then you're told C does occur. Well, if C occurs, then W occurs. And if you're told C does occur, then W is going to have to occur then. What if you're told, here's another statement. So right there. If blah, then orange. Whatever that means. Blah, 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 blah. If blah, there's your hypothesis, then orange, there's your conclusion. If blah, then orange. Here's a statement. Let's assume that's a true statement. Then let's say you're told orange occurs. Orange occurs. Can we make a conclusion? Nope. Just because this happens, there's actually, the arrow's going this direction if you're going to draw that. Remember, the arrow's going that direction from here to there. From here to there. The if then, from the if to the then. if this occurs, it does not necessarily mean that has to occur. It's always going that way. If this occurs, that has to occur. But if this occurs, we don't know if this does or doesn't occur. So if blah, then orange, and then you're told orange occurs, there's no conclusion possible. Okay. Next part is the law of syllogism. The law of syllogism. Okay. It states, if hypothesis P, then conclusion Q. If hypothesis Q, then conclusion R. So if you're given that stuff, and those are true, your conclusion would be, if P, then R is going to occur. So let me give you another example. Move that out of the way. Let's say you have this stuff. Okay, and you give it like this. If C, then W, and if B, then C. Can we make a conclusion? So I'm going to take these and rearrange it so it's like this. Okay, I want the second part of this one to be the same as this. Is that true? Is this second part of this one, is it the same as this right here? No. So right now I cannot do anything. So I'm going to change the order. I'm going to write it sort of like that. So we have this one here. We have that one up top. If B, then C. If C, then W. Are these the exact same thing? Yes. So now you can use the law of syllogism. If B, then C, and if C, then W. The conclusion would be is, if B occurs, then W has to occur. In this way, it's a lot easier to see, but when it's drawn that way, that's a lot more confusing. So I'm just drawing it that way. It's just easier to understand that way. Okay. What about if I give this stuff? Here's a case of if blah, then yada, whatever the heck that means. And the next one would be if blah, then orange. What? So I'm going to take these, instead of side by side, I'm going to write it like this. So this one, and then down a step. If blah, then yada, and if blah, then orange. Are these the exact same thing? No, they're not. So right now it's not going to help me. What if I switch the order and write it this way? So I have the second one above the first one. Now, if blah, then orange. And this one says, if blah, then yada. Are these the same thing? Nope. So they're not the same thing here. They're not the same thing there. You cannot make a conclusion in this case. You cannot use the law of syllogism. What if I turn them over? No, that's not that one. Let me give you another example. Okay. Here we have if x is greater than 2, then the absolute value of x is greater than positive 2. And the other statement is, if x is less than negative 2, then the absolute value of x is greater than 2. Side by side, it made me confusing, so I'm going to take these and scooch this so it's right underneath that one. Are these the exact same thing? No, they're not. Then let's switch the order. Okay? Switch it this way. Now, are these the exact same thing? There's a 2, there's a greater than, there's an x. Oh, that's an absolute value of x. That's not an absolute value. These two are not the exact same thing. So they're not the exact same thing in this case. They're not the exact same thing in this case. Therefore, you cannot use the law of syllogism. It doesn't work. What happens if we have a different scenario? Let me use this. If hurry, then purple, whatever that means. And then we have if quickly, then hurry. So what if we just write it this, sneak this? Are these the exact same thing? Nope. So you cannot use a law of syllogism there. What if we switch it and do it this way? Okay. If quickly, then hurry. If hurry, then purple. Are these the exact same thing? Yes. Here you can use law of syllogism, and that would be if quickly, then hurry, if hurry, then purple. So that means that by the law of syllogism, if quickly, then purple. If that happens, if quickly occurs, then purple will occur. Okay? That's the law of syllogism. And that's basically, one of these is question 21. It's this one right here. That was question 21. Good thing I did that. Question 17. Question 17 states, use the law of detachment. Okay? Use the law of detachment. Determine what you can conclude. If you pass the final, then you pass the class. So we're saying, let's use the back side. If you pass the final, if you pass the final, then you pass the class. Okay. If you pass the final, then you pass the class. The next statement says you pass the final. Okay. So you pass the final. Is this the same thing as this? No. Is this the same thing as the hypothesis? Yes. So that means if this occurs, then that has to occur. So based upon this information here, if you pass the final, then you pass the class. Well, and this states you pass the final, therefore you pass the class, according to that statement there. If it said, let me write this one down. If it said that if you pass the final, then you pass the class, and then you're told you pass the class, does that mean you pass the final? Not necessarily. Okay, remember, this stuff, the order is going in this direction only. If this stuff after the word if that happens, then the stuff over here, if this is a true statement, then the stuff, if this occurs, then that stuff over there has to occur. Okay? This is the same as the conclusion. If this occurs, the arrow is not going that way. If this occurs, it does not mean that this does or does not occur. So here you cannot make a conclusion for question 17. Okay? Good luck, guys. Bye.